In this lesson, we will be multiplying polynomials and we will be using our exponent rules or our exponent laws. You see here that we have a 2x to the fifth times a negative 5x to the fourth. So we're including coefficients and variables in this problem. So we're going to look at our coefficients first. We have a 2 times a negative 5. Well, 2 times a negative 5 is simply negative 10. Well, then our variable is x, and we have x to the fifth times x to the fourth. Well, remember, when you're multiplying and you have the same variable, you can take the exponents and add them. So that's negative 10x to the ninth power. That was 5 plus 4. 5 plus 4 is 9. So 2 times negative 5 is negative 10, and x to the ninth. Now, in this example, you'll see here again, we have a coefficient and a variable, but we have an exponent raised to a power. So we have a power to a power. So we have to consider multiple rules here. So we have a negative 2x squared raised to the third power. So let me just go ahead and write this out. This means basically we have negative 2x squared times negative 2x squared times negative 2x squared. Now, you wouldn't have to draw this all out, but I'm just showing you. This is what negative 2x squared to the third means. We're multiplying this times itself 3 times. So this 3 applies to the negative 2, and it applies to the x squared. The 3 applies to everything inside the parentheses. So we have a negative 2 times a negative 2 times a negative 2. Well, 2 times 2 is 4, and with these two being negative, it becomes positive. Negative 2 times negative 2 is positive 4. But then we have 4 times negative 2, which is negative 8. So we have negative 8, and then our x squared, x squared times x squared times x squared. Well, we just add up the exponents, 2, 4, and 6. So our final answer is negative 8x to the sixth. And that would be your final answer, okay? And again, we're basically just simplifying these expressions, okay? We're not solving for x right now. We're just simplifying the expressions.